Lesson 4.2, implicit differentiation. Gonna knock you back on your heels a little bit here, but it's not a big deal. It's really not a big deal. Just get used to it. So how do we find some weird equation that's not set up in a nice little f of x equals or y equals? What do? Well, we apply the derivative to each term. d dx x to the third plus d dx y to the third minus d dx, I probably should have put the negative inside, but it does not matter, equals d dx 0. Now, here's the hard part, and I don't even think it's hard. Here's the part that first few times are like, it's kind of confusing. Yeah, it's no big deal. Derivative of an x is simple. It's 3x squared. Derivative of y, you treat it the same way, but don't forget we got chain rule. Well, what happened to the chain rule here? It's right there. It's an invisible dx dx, which is 1, so we never bother. But when it's not x, we got to chain rule the inside with that. Now here, I'll put parentheses, leave it, dy dx plus 9 derivative of x is 1, y equals 0. All right, now we're not done. Like, I don't know what just happened. Yeah, it's a piece of cake, though. You don't have to worry about what just happened. What you have to worry about is how do you get dy dx alone? Well, you throw all the dy dx's on one side and factor them out. So dy dx, right here, there's a 3y squared glued to it. Over here, there's a minus 9x. Now on the other side, there's a negative 3x squared. This is a minus 9y, so when I move it over, it's there. And then we just divide both sides by 3y squared minus 9x. So like many things in calculus, the first time you see it, it just makes you want to cry. And then after that, you realize, oh, wait a minute, this isn't so bad. And this one truly is like that. Chain rule is, that was really complicated. Yeah, and it's hard. It's hard. That's called implicit differentiation. Let's see if we can figure out what's going on with this. Now, we need 2 points. I'd go with 0, 0, except there's this one and this one. So I'm not sure what's going to happen. Derivative might be undefined. It might be 0. Oh, look, it's undefined. Oh, look, it's also 0. Which is it? Well, it depends. I mean, that's complicated stuff. How about, looks like 2 comma 1/2 is a point. Let's plug that in. I should get a number like about 1/3. Oh, actually, I can almost read this off. It goes up 1 over 2. I should get about a 1/2. So dy dx x comma y equals 2 comma 1/2 equals, and I'm just going to slap this together on my own. The bottom would be 3/4 minus 9/2, which is 3/4 minus 18/4, which is 3/4, 3 minus 18, negative 15/4 on the bottom. And on the top, we would get negative 12 plus 9/2. Assuming I did that right, which I don't really trust myself. Why did I call this? That's so wrong. And enough of that. Let's get a calculator involved. 3 times, try again, negative 3 times 4 plus 9 times 1/2 over 3 times 0.5 squared minus 9 times 2. And math, enter, and I get 10/23. And I said it should be pretty close to 1/2. Up 1 over 2. 1/2 is 0.5. So this is like 0.4. Not bad, not bad. So it works. Just kind of interesting. There's some crazy math going on here. This is called implicit differentiation. It's just, implicit means not done the usual way, which I looked it up, thought there'd be some really fascinating story, but there isn't. So y squared equals x, and we apply our d dx on both sides. 2y dy dx equals 1. dy dx equals 1 over 2y. Problems? Y On the right, whoops. Yeah, that's fine. It's not a problem. It's no problem. You know, a lot of times we've done these problems, we've said, what's the X and the Y? It's like up here, I needed the X and the Y coordinate. It's no big deal. Is there another way to do this? Let me see. Y squared equals X. I can throw in a square root, which means I get two problems. Plus square root of X, Y equals negative square root of X. Y dy dx equals 1 over 2 root X, or 1 over 2 root X. That's not what it says here, though. Yeah, but Y equals square root of X, so 1 over 2 root X, or 1 over, hey, it works. Same thing. Wow, that's really cool. What if yeah, shut up. So, I mean, I could put 1 over 2 y squared, square root of y squared is 2, you know, that sort of thing. The interesting part here is that there's no negative here, and there is up here. So how does that play? It doesn't matter. It doesn't matter. Let's find out. Let's graph it. Y squared, y equals x squared, therefore x equals y squared. Oh yeah, you don't have a function here. Interesting. But you could find the derivative. So, and don't forget, derivative equals slope. Like I just showed you. Here, plug in 0, I get an infinite slope. Doesn't work, and that's really horrible. I know it's below the line. Go. And here, 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 here. That sort of thing. So that's slope. So now we get to do some weird kind of problems. This is not a function. It's a circle. 1, 2, 3, 4, 5. Oh, that is really good. For some reason, it looks like a baseball, but that is really, really good. Slope at 3, 1, 2, 3, 1, 2, 3, 4, right about here. It's going to be a little bit less than 1. I love using the word ish. So let's go. ddx this sucker. So 2x plus 2y dy dx equals 0. 2y dy dx equals negative 2x d. What the heck happened here? That's so weird. Dy dx equals negative x over y. Nice. So 3 dy dx x comma y equals 3 comma negative 4 equals 3/4. Yeah, let's make that 0.8-ish. So that was 0.75. It works. And the answer is yes and no. Not at 5 comma 0 and negative 5 comma 0. Because we're dividing by 0 and it's an undefined slope. But otherwise, it works beautifully. So, how did I graph this? Where did I get that graph? Desmos. Show that the slope is defined at every point. Yeah, whatever. That means that there's no 0 to be made. There's no denominator that turns into 0. So, all right. So 2 dy dx equals 2x plus cosine of y dy dx. Cool. Send that over. Which way should I subtract that or that? It doesn't matter. Dy dx 2 minus cosine of y equals 2x dy dx equals 2x over 2 minus cosine of y. Since cosine of y -1 less than or equal to cosine of y less than or equal to 1. Denominator cannot equal 0. All right, so application, lenses, whatever, some weird ellipse thing. It's what do they call it? Rotated. I cannot believe I struggled that hard with the word rotated. But that's what happens when you rotate it. You do a sine and a cosine thing. I've seen it before. It's been ages since I tried it. And you end up with a term in the middle instead of your typical x squared plus y squared equals, that sort of thing, like a circle. So find the tangent normal at 1, 2, which I very nicely already pointed out for you. All right, we can see it's going to be negative 3.5. We can see it's going to be 1.75. So let's find out. 2x minus, leave it, dy dx, minus 1, leave it, y, plus 2y, dy dx equals 0. I did it wrong. dy dx, I put my 2y minus x equals y minus 2x over 2y minus x, y minus x by. They gave me the point. Nice. I don't have to go mess with that. Let's go find the derivative. I've been doing this all sorts of different ways. I'm going to do this. I wish I knew which way was right. Let's just say it's that way. So xy, 2 minus 2 times -1 over 2 times 2 minus -1. That was weird. 2 plus 2 equals 4. 2 times 2 is 4 plus 1 equals 5. So 4/5. All right, so here we go. Tangent line, y minus 2 equals 4/5. X plus 1 plus 2. Now, how do we do? Oh man, I can't tell. 4/5 plus 2 is 2 4/5, and this is the tangent line. That's tangent line. So it's 2. Man, I was looking at the x intercept. Weird. 2.8. Pretty darn close. Normal line. Y equals -5/4. X plus 1 plus 2. -5/4 plus 2 is -5/4 plus 8/4 is -3/4. 3/4. Spot on. Oh goodness, I've been off page. Sorry about that. All right, that's the normal one. Now, this gets a little hard. Not the end of the world, just kind of a hassle. So, second derivative. This you'll see on the AP exam. It's a nice little problem. It doesn't take forever. It makes you work for it. Won't be a super nasty problem, but yeah, you get the idea. So we get 6x squared minus 6y dy dx equals 8. Can't believe I just did that. 0. 6y dy dx equals 6x squared over 6y. Dy dx equals x squared over y. Second derivative, d squared y dx squared. I don't know if I got around to telling everybody this, but that's like saying d dx of dy dx. So there's 2 dx's, dx squared. This is only a d, so it's a d squared of y. There's 2 d's. That's why we write it that way. And it actually matters, but you don't need to worry about it. Equals low d high minus high d low over low squared. Well, what in the world are we supposed to do with that? 2xy minus x squared over y. X to the fourth over y over y squared. We need another y over y here equals 2xy squared minus x to the fourth. Extra y here, bring it down, y to the third. By the way, this freaks people out when I do this, so you better get used to it. It's not that hard, but a lot of people are just, oh, what just happened? All right. Just for fun, we've already done this. We've done this quite a bit, but I never really said it officially. 1/2 x to negative 1/2, and I always jump and go with 1 over 2 root x. Now, normally I would rationalize that, but you don't have to in this class. Yes, that's right. All those teachers lied to you. Tragic. Equals 2/3 x, and that's where life gets a little goofy. 2/3 minus 3/3, negative 1/3, which is 2 over 3 third root of x. Do I care if you leave it like this or that? No. Do I care if you write it 2 over 3x to the 1/3? No, but multiple choice. Who knows how you're going to see it? And this, of course, negative 1/5 cosine to the x to the negative 6/5 times negative sine of x. Chain rule equals sine of x over, I would probably just go like cosine x to the 6/5. Probably how you're going to see it. Of course, you can leave it up top. I don't really care. That's it. Good luck and happy mathing.